what are the solutions? So for this problem, especially because I have color up here, we have the green dots up here would be gray if you were looking at these on Desmos. But remember, our solutions are our x-intercepts. Solution includes x-intercepts, solution set, all the same. So this crosses the x-axis at -1 and at 3. Good with that? There are problems on the OST that are that simple. One. What values of x make the equation 4x squared minus 21x minus 18 true? So you could absolutely factor that. You could factor and set those factors equal to 0, or you can put this into Desmos and graph it. And when you do that, your graph looks like this. Pulled over really big. Now, I'm going to make it smaller, but not that small. So on this graph, this, of course, like you can't see the vertex. It's going down, down and back up. But again, when we're looking for solutions or what values of x, we're looking for these x-intercepts. One of them's nice. 6 is a nice point. Negative 0.75 isn't too bad. Solutions, x-intercepts, values of x that make the equation true. Again, in this review, we're just trying to talk you through all of the ways that a standardized test could ask you for that information. Okay? Put it in Desmos, graph it, look at the graph, where does it cross the x-axis? Now, sometimes sometimes you'll get something like this, which is the factors form of the function. So this is multiple choice. Again, you can factor it, but if you're looking at this and you're like, that is super nasty to factor. Okay, so let's try to get rid of some options and then we'll put it into Desmos and use guess and check. That's the way I would do this on a standardized test. So first, when we're working with a polynomial, when we're trying to factor, some of these have, like if I look here, is 2x times x would give me 2x squared. Would that get me back to that? No. Okay. No, thank you. 2x times 2x would give me 4x squared. So I like that one okay. This has a 2 out front. This has a 2 out front. That 2 out front would be a GCF. So let's look up here. Can I pull a GCF out of 4x squared, negative 22x, and negative 42? What do all of those have in common? What can I divide away? 4 is divisible by 2, 22 is divisible by 2, and so is 42, right? They're all even. And if they're all even, we can definitely factor out a 2. So I'm thinking that this option and this option are looking pretty good. I did get a 4x squared here, so I'm not going to totally get rid of it. So here's what you're going to do. If you want to do, I would rather use Desmos than factor. Okay, that's lovely. Let's use Desmos instead of factor. What we're going to do is we're going to put that original equation in, that 4x squared equation. And then we're going to put in our other options and see which one gives us the same graph. So our original equation was 4x squared minus 22x, x minus 42. There's our original graph. And then I said that I wanted to check C or D first. So I'm going to put in C first. And I'm going to put it in exactly how it looks. 2 times 2x plus 3 times x minus 7. And see if it gives me the same. Oh. Let's make sure. I'm going to zoom out so I can see that whole parabola. It's a really tall one. And then I'm going to double check it just by turning that off and turning it back on. They're right over top of each other. Okay? That means those two are equivalent. So this is the one we just put in. Now, I factored out that 2 just to make putting things into Desmos a little easier. You could absolutely just say to yourself, I don't know, I'll try B. And put B in. So B was like this, right? And then you can see, okay, those are not right on top of each other. All right, I'm going to try D. Or start with A and try them all. Okay? On a multiple choice question, that's absolutely a fine way to factor. Next. Now we have to factor. This is use the zero product law. It also, like, there are problems on the OST that will give you a box and they'll ask for a factor form. You guys remember that? We really stressed that during when we were working on Quadratics. So factored forms, to get to factored form, we do this. We do A times C is the key. 1 times 30 is 30. I need 2 numbers that multiply to 30 and add to 11. Here's my factor tree for 30. And again, your factor tree is just divide by 1, divide by 2, divide by 3, and you're looking for those whole numbers, right? Now, the combination that adds to adds to 11 is 5 plus 6. So we change our 11x into 5x plus 6x. We bring down our x squared. We bring down our 30. And then we're going to cut our problem into half and just do GCFs. The first 2 terms are always going to have at least x in common. Here it's just x. I'm left with x plus 5. And remember, with some of you, if you came in and worked with me one-on-one, we really did a lot of that, and that was really helpful. Knock those terms away. 6 and 30 have 6 in common. And I know that this should match this, right? When I divide by 6, again here, those 6s, that becomes 5. So my factored form isn't this. My factored form is 2 sets of parentheses, x plus 6 times x plus 5. So that's your factored form. And then to find your solutions, you set them both equal to 0. And you can absolutely, so if you hadn't been asked, on this problem, if you were thinking like, I would just put it into Desmos and find where it crosses the x-axis. That's lovely. This problem crosses the x-axis at -6 and -5. I'm showing you guys factored form today so that you remember that factoring is a thing. So that when we get to the OST, you can do this piece if you need to. I'm only going to factor on one more problem. This line. A times C is the key again. 3 times -8 is -24. I need 2 numbers that multiply to -24 and add to -10. So now we have some negatives happening. Okay? So I'm going to do the factor tree for 24 pretty quick here. 2 and 12, 3 and 8 is what we just did. 4 and 6, 5 doesn't go in, and then I'm to 6. This one's a little tricky because when I was thinking 10, I haven't done this problem in a couple days, and I was thinking, oh, 6 and 4. Except if I'm multiplying to a negative, I need one negative and one positive. And 4 plus negative 6 would give me negative 2. So that's not our combination. This would give me negative 5. So we're getting closer, but that's not our combination. There's my negative 10. So my first term's going to stay the same. My negative 10 is going to turn into 2x minus 12x. That's the same as negative 10. And then minus 8. And now we're going to cut it in half and GCF. Thanks for taking nice notes, guys. It's going to help you. You got to get this stuff kind of back in the front of your brain instead of where it's kind of moved to the back because we've done some others. Our first two terms always have x in common. Here they just have x in common. So if you like that visual, knock those x's away. 3x plus 2. This one's a little tricky with the negatives over here. So the negative has to come down here. 12 and 8. 8 doesn't go into 12. 4 goes into 8. 4 goes into 12 as well. So what I'm dividing by, what I'm taking out is that negative 4. And that's helpful. So negative 12x divided by negative 4. Negative divided by negative is going to be a positive. 12 divided by 4 is 3x. Negative 8 divided by negative 4 is positive 2. And now here are my factors. And you don't have to be worried. Order does not matter. So if you are asked for a factor form for this guy, and you type that in, and the person 3 seats away who gets that same question swaps those and types that in, those are the same. They're the same answer. Order doesn't matter. Okay, set them both equal to 0. Again, you can get the solutions by graphing this. And I definitely, even if you're like, factoring's my favorite, because your name is dyslexic, I would still put that into Desmos and double check. Am I really crossing at x equals 4? Because it's easy when you're doing this much math to make a little sign error and you don't, again, these 20 problems that you are going to get, they have to be perfect. So if you put in negative 4, now that's not one of your 20 anymore. Okay? Whereas in here, if you made a sign error, I didn't, you know, we like good process. And then we just have that 2-step equation there. Move your 2, divide by your 3. All right, we can get the next 2 problems done in approximately 30 seconds, and then you can do some of these on Canvas. So if we graph this on Desmos, and maybe I'll do that real quick while some of you are finishing this up, it should cross our x-axis at 4 and at negative 2/3. So we just did what? 3x squared minus 10x minus 8. Is that right? And if you're not sure if negative 2/3 is the same as negative 0.67, negative 2 divided by 3, and now I'm feeling really good. Feeling really good about that answer. I'm like, okay, there's one of my 20. I think, if I'm remembering correctly, it's only 30 out of 54 that you have to get right for a 4. Still not a huge percentage of those. If you get a problem like this and they ask you to find the zeros, they have it set up for you. what you have is two little baby equations that you just need to set equal to 0 and solve. I got that as a problem in the OST. I do a little happy dance. Maybe like not. Big happy dance. So just set those two little baby equations equal to 0. Move your 9. Move your 1. You can also, this one, you can still put that into Desmos, just with the parentheses. Put it into Desmos and double check that you changed something. Okay. The graph of a quadratic intersects the x-axis at -4 and 8. What is a possible equation? This is a problem that we've seen on the OST many, many times. Here's how it started. X equals -4, x equals +8. I'm writing that right above my answer blank on purpose, and you should too. And here's why. All we need to do is all we need is to take these little guys and make them into factor form. That's an equation. So what we did here was we took our we started with x minus 9, which is one of our factors, and we moved the 9 over. So to go backwards, we would move the 9 back by subtracting it, right? We would move the 1 back, and it was positive over there. So using that same pattern, here we're going to move our 4 over to be with our x. So in the parentheses, we have x plus 4. We're going to move our +8 over by subtracting it. So in our parentheses, we have x minus 8. And you can check that, and I would, again, this is not about getting problems done, it's about getting a certain number of perfect problems. And because of that, I'm like a way over checker. So we said it was x plus 4 times x minus 8. That's what we put in. That's the equation that we wrote. And it is crossing the x-axis at -4 and at +8. All right, for your last problem. This is a special factoring situation because everything is a perfect square. 9 is 3 squared. X squared is x squared. 16 is 4 squared. So the way that we factor this is a difference of squares. One of our sets of parentheses is positive, the other is negative. And then those square roots just plop into the parentheses. The 3 and the x have to be together because the 9x squared was together. The 4's have to go kind of in that second blank in each of your factors. We always see some difference of squares factoring too. I think those are, difference of squares factoring is easy if you recognize it. It's really hard to recognize sometimes, I think. So. Okay, so if you're feeling good about quadratics right now and you're like, I bet I can bust through these problems on Desmos super quick, work on those. At this point, you can also go back and work on any of those quizzes that you need to.